is absolute value equations and inequalities. And I've got three sort of formulas or cases written on the board. And now you can write those down and memorize them, by all means. Go for it. But I recommend we really understand why they work first. So I'm going to try to explain why they work for each one. I'm going to start with simple numbers. I like the number 4, so I'm going to use the number 4 for all of them today.
Is that dot part of it, or that's
No, that's just, this is like case 1, the bullet points. Okay. Case 1, case 2, case 3. Sorry. I'll give you guys a second. I know you guys want to write that down. I know you do. Anxious. You want to have it written down. I feel very awkward that you're recording.
I try not to laugh because I was listening to them and I'm loud on there.
While you guys keep writing, let me just talk, because I just want us to understand why. This isn't even an example. I just want us to understand why. If I had something like the absolute value of x equals 4, the idea in solving these is you're trying to figure out what number makes it true, right? So what number could I plug in here to make this equation true?
4.
4.
Negative
and
4.
Negative 4, right? Yeah. Do you guys agree that x could have been 4 or negative 4? Good, right? That's pretty straightforward, right? Because the absolute value of negative 4 was positive 4. So because of that, 4 and negative 4, that's where I got a and negative a in that formula. Easy enough, right? Let's do the next one. What if I were to give you the absolute value of x, I have less than, is less than 4. Let's think about what numbers make that true. Think of any number. I'm going to think of 2. It's the number 2. I like the number 2. Does 2 make this true? Yes. What about negative 2? Yes. What's the absolute value of negative 2? 2. Is 2 less than 4? Mm-hmm. What about negative 6? No. What's the absolute value of negative 6? 6. Is 6 less than 4? No. So when you look at this, and I'm going to visualize this one for you guys on a number line. Here's my 4 and my negative 4. We all agreed that this number 2 worked. This number negative 2 also worked, right? But negative 6 did not. So really it was the numbers in between that worked. Open parentheses because I don't have that equal sign. Do you guys see how those are the ones that worked? So what we're saying is that x is between 4 and negative 4. That's what that notation is, and that's where that came from for that second case. X is between negative 4 and 4. Can you guys see that okay? Yes?
Did you, the green markings, are they supposed to be there? Or?
Yeah, so what that means, those green markings over here, it means that if I did have an equals underneath, then these would both be equals. If I didn't, they wouldn't be. That's all that I meant by that. In this case, it just didn't have one. All right, and then what about the other one, the absolute value of x, let's say greater than 4? And thank you for bringing that up. That would be the same here. If this had an equals, those would have an equals. All right, absolute value of x greater than 4. Let's think of some numbers that make that true. Somebody yell at a number that makes it true. 5. Absolute value of 5 is 5. Is 5 bigger than 4? Yes. Another number. 7. Negative 10. What's the absolute value of negative 10?
10.
Is 10 bigger than 4? Mm-hmm. See how some negatives and some positives worked? So if I were to draw that on the number line, here's my 4 and negative 4. You guys were saying 5 and 7, and all those numbers worked, right? And then all of those numbers also worked? Would the number 0 work? The number 2? Negative 2? No. So that's what we're saying by the x is bigger than 4, that's this guy, or means union, and then the x is less than negative 4, that's this half. That's where that's coming from, and that's that third case. You guys see kind of where it's coming from now?
Yeah.
Okay. Yeah.
Does this apply to the same thing like brackets are only for the y?
No, brackets are for if I have equals. Like,
oh, okay.
Thank you, yes, thank you very much. That if I have the equals underneath, that's when the brackets are coming into play. Absolutely. Okay, so that's sort of where it comes from, but obviously those questions are far too easy. Am I going to ask you them on a test? Yeah. Of course not. Of course not. So what we got to do is understand them on a little bit more involved level. So example 1 from 3.5. And they're all going to say solve. Okay. And I'm going to want you to write an interval notation if possible. Not all of them can be written in interval notation, but if possible. Nice and simple, straightforward. Absolute value of 3x minus 1 equals 8. First thing you need to identify is which of the 3 cases it follows. Which one? The first one, because I have an equal sign, right? Not an inequality. So it follows along with that first one. And that first case was I had the x equals 4 or the negative 4, right? That's what we had written over there. So what I'm going to do, the way you break it up, is whatever is inside the absolute value equals the 8, or whatever is inside the absolute value equals the negative 8.
That's how you break it up.
Yep. And you break it up, just how we broke up. So looking at case 1 over there, see how the question had an absolute value, and then the broken up did not have an absolute value? It's the same thing. The question had an absolute value. Once I break it up, I don't keep the absolute value.
7/3.
And then you just solve. Then it's easy. Get x by itself. Add 1 to both sides. Divide by 3. Same for the other one. Add 1 to both sides. Divide by 3. Is there going to be an interval notation here? No, because the interval notation only comes from the inequalities. So in this case, I just have 2 answers. And you can do curly bracket, 3 and negative 7/3.
Isn't it supposed to be equal 7/3?
I don't care. Mathematically, it does not matter. It's only silly viewing examples that don't matter.
My math lab would be picky.
Yeah, you're probably right. I'm sorry. You probably should do it in numerical order. But I'm going to be a rebel today.
Good.
Questions on that one? Yes, sir.
Do the parentheses have to be like that?
Those curly brackets, you don't have to. No, on my test or quiz, you could have just circled those 2. On your My Math Lab, they will have those there for you, and they'll want the comma in between. I'm certainly okay if you just circle both of you. All right, let's do another one. So same directions for all of them. Okay. Let's do this. Let's do that. Does this sound familiar to some of you guys?
Yeah.
Okay, good. It's nice to have a little bit of an easy day, right? Because I think last Thursday was hard, so
Yes.
today's a little easier.
Homework was so hard, I thought.
It
Yeah.
was really hard.
Thursday.
The last Thursday.
I almost started crying.
I'm so sorry.
Yeah.
Now you know how I feel when you guys put axis of symmetry is 4 instead of x equals 4. I start crying.
I remember I did this last year, but we changed the side it's facing and put it as a negative.
Yes. Well, let me write it. I'm not sure if the way you're wording that is the correct way to word it, but let me write it and see if that answers that question. So, first of all, is this the second case? Yeah, so let's start off with the less than, right?
What's the difference between the second and third?
See, the second one is a less than, and the third one is a greater than. The direction of the inequality.
Okay, but you split them up differently.
Yeah, you split them up differently, yeah. You have to look at how it starts, and then you look at how you split it up. So this one looks like that. Second case, so I keep whatever is inside that absolute value has to be in between the positive number and the negative number. Did that answer that question? Okay.
I just did 2 different.
You
Like how
can,
we did the first one.
yeah, you can. That would make it harder. I recommend you do this time.
Okay.
Just my recommendation. Okay, so then what I do here is now I just solve. Do you guys see how I had positive on one side, negative on the other? There was positive A on one side and negative A on the other. So now I'm going to subtract 2 from all 3 sides. And that's going to give me negative 29, less than or equal to negative 5x, less than or equal to 25. Yes?
So with this example, that's when you have to get the x by itself, right?
Yes.
Divide by 5.
Divide by
Negative 5. We switch the sign.
And that flips the symbols absolutely. So this becomes now a positive 29 over 5, right? Two negatives. And now this becomes the flipped direction.
That's where
Yeah.
stuff.
And then this becomes what, negative 5, I think?
Yeah.
And now the way you write this in interval notation is x is between negative 5 and 29/5. Do I have brackets? Yes, because there's equal signs, right? This is the one where it does, order really does matter for the interval notation. You have to do the smallest first. Easy enough, right? Questions on that? I'm going to do a couple of trick questions then too, because I don't want to do trick questions to throw you off.
Three. Example 3.
Oh, thank you. I thought you were just saying 3 because you thought the answer was 3, and I was really
Oh, did I already get the answer?
No, that would be cool. I would get the answers too. Okay. Same question. Solve, write it in interval notation if you can. First of all, what case is this? First, second, or third? Second. But here's what's different about this one. This case, I have some numbers with the absolute value, right? The point is, for all of these absolute value equations and inequalities, the absolute value must be by itself first. Then you can break it up. So my absolute value is not by itself, right? I need to bring this to the other side. So how do I do that?
Add 2.
Gotta remember that. That's one thing a lot of people forget. Don't forget that. The absolute value has to be by itself first. Then you can break it up into one of those three cases. So then this becomes the absolute value of 3x plus 1 is less than negative 2. Okay, so now you guys all agree this was case 2, right? All right, so take a second. See what you guys can do. See what you can do to solve this. I'll give you a hint. It was a trick question. Let me do this. Let me think of a number. I'm going to pick a number. My favorite number is 4. I'm going to plug it in and see if it works. 3 times 4 is 12 plus 1 is, absolute value of 13 is?
13.
Is 13 less than negative 2? Okay, so that didn't work. Maybe negative 4? Try negative 4. 3 times negative 4 is negative 12. Plus 1 is negative 11. But what's the absolute value of negative 11? Is 11 less than negative 2? Now you guys do it. Pick your favorite number, any number in the world. Could you make this true?
0.
Never going to be true.
How do we know that?
How do we know that? Look at this right here. The absolute value is always positive. Right? Because no matter what number you have, when you have that absolute value, it turns into a positive, right? So a positive less than a negative will never happen.
No solution.
Positive less than a negative will never be true. And you don't have to write that in like the test or anything. I'm just writing that so you have that in your notes. Anytime you have a positive less than a negative number, it will never be true. So there's no solution. And you can write that as this symbol if you want. That means no solution.
But if we worked that problem out, what would we get?
You probably would have got like one. You probably would have got some numbers, and you would have thought you got it right.
Yeah.
You would have got wrong.
I just won.
Well, I had like a 1/3 and a negative 1.
1/3 negative 1.
It's wrong. You think you got it right, huh? No, it's wrong. You had to stop. The point of this is to make you think. Because you could have worked it out. You would have got some numbers, and it would have looked fair enough. But it was wrong. Trick question. That's a good one. Let me do another one. Do another example. What am I at? Example 4, right? So let's do 3 minus the absolute value of 5 minus x plus 4 is greater than, let's just say 1. No, I'm going to make that less than 1. I think. Is that going to work? Hold on. Don't write it down yet. I'll make sure it works. Yeah, that'll be good. Let's do that. Okay, what's the first thing I should do?
Move the absolute.
I gotta make sure the absolute value is by itself first, right? There's definitely more than one way you could do this. You could move the absolute value to the other side. I'm gonna subtract 3 from both sides, and then subtract 4 from both sides. You guys see that? That's one way. What you were doing is right, I'm just doing it a different way. And then this would become negative absolute value of 5 minus x is less than, what is that, negative 6?
Yeah.
You got that so far? Then what do I do?
See?
Divide by negative 4.
There you go, divide by negative 1. The absolute value has to be by itself first. So if I divided both sides by negative 1, then I would have the absolute value of 5 minus x. What would happen here? Greater than and a positive 6. You guys see that one? Subtle trick. Subtle trick. That one's not too tricky, but it's there. Okay. Then what do we have to do? Now the absolute value is by itself. We have to identify which case it is. Which case is this one?
Third one.
The third one. Finally, I haven't done a third one yet today. So the third one, I break it up with that word or. Right? So that's going to be the 5 minus x is greater than 6, or 5 minus x is less than negative 6. Remember, what's inside the absolute value stayed the same. It's the other stuff that switched once I broke it up. Have I lost you completely? It is okay. I can never tell. You have such a quiet crowd. Nothing. No response.
I worked
Zilch.
out the other one, it came out as a negative, so we ended up flipping it all back anyway.
That's okay. Sometimes you gotta flip it twice in one problem. There's nothing wrong with that. So what did you do? What's the first thing you did? You had to subtract 5. So we subtracted 5 first, and they ended up with negative x is greater than 1. When you divided by the negative 1, that meant x was less than negative 1, right?
Mhm.
Yeah, you did have to flip it again. That's okay. Do the same thing over here. Subtract the 5. Negative x is less than negative 11. That becomes x is bigger than now positive 11. Now you could draw this on a number line. Here's my negative 1, here's my 11. X is greater than 11, doesn't that mean to the right side? And x is less than negative 1, so that means to the left side. So how do I write that in interval notation?
Negative.
Union.
Union, right? That's where that or is coming from. That word or is the union. And then here, that's the 11. Excellent. Questions on that? Good. Negative number. Right. Again, let's write that down. This is always positive, and that will always be bigger than a negative number. That is always true, right? So that means it's all real numbers. A lot less work, right? You got to pay attention to those ones. Those ones are tricky. Are there questions on that? It's a good one. I like that one. Let me throw one else at you just to make sure you guys are awake. Absolute value of x minus 1 equals negative 3. No solution. Done. No work. Why is it no solution?
Because it's never going to be true.
Absolute value equals a negative will never be true. You guys see that? Just make sure you're paying attention. Once you have that absolute value isolated, pay attention to whether or not you think it's even possible to be true before you start breaking it up into different cases.
So absolute value can never equal negative.
That's right. Absolute value can never equal a negative. Absolute value can never equal a negative. Okay. So far, so good?
Mm-hmm.
I'm going to do a different one than what I did this morning. Spice up our life a little bit. Ooh, good one. It's a solid. It's a fair one. First thing we do is make sure that absolute value is by itself. Okay, check. Second thing we do is identify which of these cases, right? First of all, is this going to work? Yeah, absolute value less than positive 1/2. This will have an answer for sure. So this is part of the second case, am I right?
Yeah.
So that second case is I take whatever's inside the absolute value and pop it in between the positive and the negative. You guys remember that? That's just that second case right there. And then we have to solve. So what I'm going to do, and there's more than one way to do this. You guys could add 1/4 to both sides, and you guys are all brilliant at fractions. I bet you would get the right answer right away. But I'm going to go ahead and do it a different way. I'm going to do this the same way we started solving things in 3.4. And in 3.4, when we had fractions, we multiplied everything by the LCD to get rid of the fractions, right? These fractions are small, but oftentimes they get bigger and harder, right? So when in doubt, get rid of the fractions. Multiply by the LCD. Anytime you're solving and you've got an equation, you can do that. So I'm going to multiply everything by what? 4 is the LCD, right? So 4 times 4 times 4 times 4 times. What's 4 times -1/2?
-2.
4 times x is just 4x. What's 4 times the 1/4? That gave me the 1. 4 times the 2 gave me the 2. You guys see that? What I did was I rewrote it so there's no fractions. Because then this we can solve a lot easier. There's no fractions. Okay? So then from here I'm going to add 1 to all 3 sides. And that's going to give me the -1 is less than the 4x is less than 3. Then what do I do?
Divide by 4.
So I get -1/4 is less than x is less than 3/4. And the way I write that in interval notation is like that. Questions on any of that? Fractions, you don't, I know, fractions are tough. Fractions are not necessarily tough. Okay, so, one more